Now let us see the smart meter architecture. So the smart meter architecture is divided into three major blocks. One is power sensing unit, second is control unit, and third is communication unit. So this section comprises of power sensing unit. This section is mainly for control unit, and then the last one is the communication unit. So in power sensing unit, the role of this block is to sense the various parameters such as voltage and current. Now this information is processed and shared with the control block. So in control block you will see there is one control unit which will process this information, and then the various applications are realized. Say if you want to break the circuit, then the processor which is there in the control unit will sense the condition of disconnect, and it will send signal to the breaker unit to disconnect the meter. And similarly the LCD control will keep on showing the various parameters. So control unit will send the information to the LCD control unit to display the parameters on the display. This control unit will also derive lot of quantities. Say for example, using voltage and current, it can derive the real and reactive power consumption and show in the display. Now after all those informations are processed, you might need to send this information to a remote server. So the third block, which is the communication unit, will receive data from control unit, and now the communication layer of the meter will see which aspect of the communication is enabled for the meter. It can be on RF or maybe on Ethernet, broadband over power line, or maybe GSM, or maybe directly the RS-485 or RS-232 cable, or maybe you have a smart card reader or the various IR modes of data communication. So the communication layer will send the data to the remote server through any of the communication channels available for data communication. Now let's see the detailed block diagram of a smart meter. What you will see when you open the smart meter, and the components which you can see in the smart meter PCB are as follows. So these are the earth as well as live, phase and neutral lines. So power is now going to the load from this side, and here you have the voltage and current sensors which will sense the basic parameters and send information to the metering SoC. SoC is nothing but system on chip, which have all the required control and the processing features such as ADC, that is analog to digital converter, CPU, that is central processing unit, that contains the microprocessor and RAM and other required things for processing, and then you have DSP, that is digital signal processing. So the information you acquire using voltage and current sensor, and then the metering SoC will process the information. Metering SoC will get power from the line. So you have the smart meter power management circuit which will supply power to the metering SoC as well as the driver circuit. This driver circuit is required for the isolation of power circuit and the communication circuit, and the required communication section is enabled for sending the data over a network. Now this will also communicate the information to relay driver circuit. So if there is a situation when the meter has to be remotely disconnected, the communication network will receive the command, and this will be shared with the metering SOC, and then this information will be sent to relay driver circuit, and it will disconnect the line and neutral wire of the power supply. And you will also have user interface so that you can see the consumption details such as real power, reactive power, voltage, current, frequency, and so on. Memory block is required to process the information as well as store the historical data for some period. When the communication fails, this information will be stored for some time, and whenever the communication is enabled, the information is sent back to the server. And we also have various security features built in the security block. We also have tamper detect block to detect any tampering in the smart meter. We also have the supervisory block. This block enables the operation and maintenance of the meter. So if there is any firmware upgrade, or if you want to do any maintenance of the meter or any reset of timer and so on, the supervisory block will provide the interface to interact with the smart meter blocks. Now there is another block for optimal extreme accuracy component. So you provide accurate real-time clock as a separate block, and also the voltage reference, so that you get the correct measurement as an output. Now let's see what is advanced metering infrastructure. Advanced metering infrastructure is an infrastructure which involves a smart meter, communication network, meter data acquisition system, and meter data management system. Advanced metering infrastructure, that is AMI, enables two-way communication between consumer and utilities. It provides a mechanism to monitor and control the consumer's electricity usage. MDAS, that is meter data acquisition system, is used for real-time data acquisition from the field data concentrating units. Those are called as DCUs, and store the data in the database. MDAS is also called head-end system. So head-end and the MDAS are interchangeably used in the utility space. So the role of MDAS or head-end system is to receive the data from the smart meters. So head-end or MDAS are used as a communication front-ender for the smart meters. They directly communicate with the head-end system, and the head-end system will receive data from a smart meter. Then it will decrypt the data packet, retrieve the required data, and store the data in the database. MDMS, meter data management system, it is used for application level processing and integration. That means after head-end system has acquired the data from the smart meter and it has stored the basic information in the database, the information is then shared with the meter data management system. Meter data management system will further process this information for various activities. Now, what is the role of MDAS? So MDAS has the user management module, then meter management module, data server, and the reporting module. So user management module is to store the user related information. Meter management module is for registering the meter in the head-end system. Data server is required to store the data of the smart meters, and reporting module is to generate various reports. Now, what is the role of meter data management system? You can see MDM as a database with analytical tools which is used for processing the metadata for applications such as customer information system, outage management system, work sequencing, and the geographical information systems. It also provides services such as remote connect disconnect, demand response management, power status verification, and on-demand metadata reading. It also provides API, that is application programming interface, between the MDM and the other software applications which require the metadata. So basically MDM is developed as an analytical tool. So whatever the metadata you receive from various smart meters, the processing of that meter data for any analytical purpose is done at the MDM level. Say for example, if you want to do customer profiling, or you want to forecast the demand, or if you want to see behavior of any customer based on his consumption pattern, those kind of analytics are built as part of the MDMS. Now let's talk about the AMI architecture, how the AMI architecture is built. So AMI architecture essentially contains smart meters, house area network. So you will see the house area network is the part of your AMI architecture. Then you have neighborhood area network and the wide area network. So house area network is confined to a particular house. Neighborhood area network contains the neighboring houses or maybe the neighboring commercial establishments, and the wide area network is the area where the data travels over a long distance. Now we require various communication equipments such as data concentrator units. So you can consider them as a repeater or the gateways. So they acquire data from various smart meters, so concentrate the data and then send the consolidated data over the network to other AMI systems such as metadata acquisition system or the metadata management system. So head-end system or the metadata acquisition system is also part of the AMI architecture. Metadata management system is also part of the AMI architecture. So all these 5 components are part of our overall AMI architecture. So at the control center level, the servers which are required for acquiring the data are metadata acquisition system, and then this information is shared with metadata management system for any processing. Then metadata management system is connected to enterprise service bus LAN, which is stabilized in the control center. In that enterprise service bus, the required metadata travels for the consumption by other applications such as demand response and outage management applications, or maybe the customer information and billing systems, or maybe development of consumer portal which will enable end consumer to see his consumption pattern. Now let's see how the information flows in the advanced metering infrastructure environment. So at the residential level, you have various activities where the smart meter interaction happens. So smart meter interacts with the home area network, which also interacts with distributed energy resources if they are in the system, and various load control devices. So this information is shared through various layers to the remote servers. So the applications which require this data are consumer portal layer, where you see the real-time information related to the consumption and the generation if you have the distributed energy resources. You have metering layer for metering of the data. With the help of DCU, this information is shared. And then the communication layer to build the communication network. So you get data either through residential or the commercial or the industrial establishment through various AMI interfaces, and then this is shared with various applications. So through communication, it is first interacting with the AMI head-end system, which shares data with MDM, and then we run various customer services. This information can also be shared with distribution management system gateway, and this gateway will share data with the distribution management system, so that the DMS can also know that what is the total load of one particular area, and accordingly it can take action for any critical condition. Say if the load is going beyond a particular limit and the load shedding is required, so DMS will invoke the load shedding application to shed the loads. Now, how metadata flows in the MDM? The head-end system will share data to metadata management system. So what are their various processes which run in the MDM? First is data input. So data is required to be given in a particular format. So it will define what format and syntax are required for consumption of the data. Then it will do the data validation. So head-end system will generally push raw data to the MDM, where it does the cleansing of the data and validation of the data based on certain business rules or the various validation rules. Then it does the exception management. So through various exception handling rules, it does the exception management. Then data editing and correction. If there is a problem in the data and it needs to be corrected, so based on various estimation rules or business rules, the data editing and correction happens. So for example, if the voltage value is coming out to be very low, it means that there is some problem with the meter data acquisition. So it can happen because of the faulty sensors in the smart meter, or maybe during communication the data has been corrupted, so data editing and correction is required. Then you store the instance of the data for any future postmortem or any analysis. So you store both raw as well as corrected data, so that you can compare in future if there is any such kind of requirement. Then you carry out various data analysis such as trend analysis or maybe reporting of various parameters to the management and so on. And then also have the option to share the data with other software applications such as billing system. So generally what happens, the billing system will track the payment behavior of the consumer, and if there is a default from the consumer side, the billing application will send the request to metadata management system for the remote disconnect, and then the metadata management system will initiate the command to the head-end system for actual execution of the meter disconnect. So these type of activities are carried out with the help of metadata management system.